Here the question says a transparent sphere of radius r and refractive index n is kept in it, right? So what they are saying, there is a transparent sphere of radius of r and whose refractive index is n, right? Now let us draw principal axis. Now at what distance from the surface of the sphere should a point object be placed? Means a point object we have to place somewhere on the principal axis. Let us keep a point object at this point so as to form a real image at the same distance from the second surface. Means the image of this point should form at the same distance on the principal axis on the other side. Whatever the distance we take here, x, the image also should be at the same distance from the other surface. These two distances should be same. That is what the question. So we have to think now when it is possible, right? Right. So now let us consider one ray along the principal axis, right? So the ray going along the principal axis won't deviate, right? Now let us take another ray in this direction. Now let us consider after refraction through sphere, the light ray goes in this direction, right? Now if after refraction again, here light ray is going from air to glass, here again glass to air, right? So here again the light ray will bend in this direction itself, right? In this direction. So we cannot draw here all. If you draw normal again, if you do that, it will take very long time, right? So it will bend in this direction. Now can this be again x? No, not possible. So if you think somewhat, this is possible only when, right? So now let us observe here. So now light ray when going from air to glass, it will deviate to some extent from its original path. It will deviate to some extent, and here when light ray goes from glass to air, it will also deviate in the reverse direction. Whatever the deviation occurred here, that will be reversed here, because air to glass, glass to air, right? That is why it is possible only when the light ray in the glass is parallel to the principal axis. If it is parallel to principal axis, what happens? Whatever the deviation occurred here, that will again reverse here, so that again it will go in the it will go and meet on the principal axis at some point which will be at the same distance from the other surface, right? So but we have to say this mathematically. Now if we consider the refraction at the first surface, right? Means after refraction the ray through the sphere should be parallel to principal axis. If it is parallel to principal axis, automatically second one will, this condition will be satisfied, right? So we will consider the refraction only at the first surface. We don't need about this all, right? So that is what. Now what is the formula for the refraction at the curved surfaces? The formula is n2 by v minus n1 by u is equal to n2 minus n1 by r. So for substituting the values, you must know what those values represent, right? So n1, n2 are refractive indices, u object distance, v image distance, and r is the radius of curvature of the curved surface, right? So now we know that all the measurements must be measured from pole surface, right? And so on the distances measured in the direction of the incident rays are positive, the distances measured in the direction of the opposite to the incident rays are negative. So sign conventions we must know, right? Now let us consider the object distance. So this is object. So direction of the incident ray is towards right. The measurement should start from pole and should go to O. So that is why the direction of the measurement is towards left, right? So both are in opposite direction. So object distance u will be negative minus x. So you can take blindly object distance as negative, because if it is in one direction, other will be in the opposite direction, right? So u is equal to minus x. Now what will be v after the refraction the first surface? We should not consider the second one. We should consider refraction at the first surface only. After refraction of the first surface, the two refracted rays, first refracted ray, second refracted ray, both are parallel. As they are both are parallel, they will form a real image at infinity, right? So that is why v value will be infinity. Then what is n1? N1 is the refractive index of the medium in which the object is present. Remember, N1 is the refractive index of the medium in which object is present. So here it is 1. And N2. N2 we should not take as, here image will be formed at infinity, right? So we should not take N2 as the, generally as it is the N1 is the refractive index of the medium in which object is present. Generally students will think that N2 is the refractive index of the medium in which the image is present, but that is wrong. Here we have to refractive index, sorry, here N2 is the refractive index of the medium in which the refraction is occurring, right? So another second medium. So here N2 as the question it is given as N as per the question, right? Now what is R? For R also we have to use sign convention. We have to use for radius of radius, we have to radius of curvature, we have to use sign convention, right? So now we know already P distance from P to C is radius of curvature, and direction we have to observe now. P to C, we should always start from pole itself, from the surface. P to C, direction is towards right, direction of incident ray is towards right. So both are in the same direction. So R is positive, right? So let us substitute now. N2 value is given as N, V value is infinity minus N1 is given as 1, U value is minus x, right? So N2 is again N minus 1 by R is positive. So R, N by infinity. Infinity stands for very large number. So 1 by large number is 0. So N into 0 is 0. Minus by minus will become plus. So it will be 1 by x. 1 by x is equal to N minus 1 by R. So therefore x is equal to R by N minus 1. So question is very lengthy, solution will be very small when you understand it, right? Thanks for watching. So that is what we have to keep the object at the distance of R by N minus 1 to satisfy that condition. The question says a transparent glass sphere has a small opaque dot at center, right? So let us consider a sphere. It has a small opaque dot at its center, right? Does the apparent position of the dot appear to be same as its actual position when observed from outside? Means apparent position means image. Will the image be formed at the object itself or else at some other place? If the image is also formed itself, the apparent position of the dot will be same as the object. Apparent position of the dot appear to be same as its actual position. Means whatever we have discussed now, right? So if the image also formed here, image and object will be at the same place. Nothing but apparent position of the dot appear to be same as its actual position. So if we general discussion, if we take some rays from this, in what direction will they be? They are all along the normal, right? So when light ray comes out of this sphere, they won't deviate. As they won't deviate, the apparent position of the dot will be same as that of the object, right? So it appears to be at the same place. Image will also will be at the same place, but we have to show that mathematically by using formula, not like this, right? So let's consider. So we have to consider refraction in curved surfaces. That's why first of all let us take formula. N2 by V minus N1 by U is equal to N2 minus N1 by R. Right? Now we have to know what are N1, N2, V, U and R, right? So once again, sphere, small opaque dot at its center, right? Now this will be C. This is only the O, object distance. Now object is in the transparent glass sphere, right? So that is why N1 is the refractive index of glass. N2 is the refractive index of the other medium from which it is observed, right? So that is why N1 is equal to refractive index of the glass. It will be N. N2 will be 1, right? And object distance. So as C is the object, let us draw one ray to the surface. So we have to measure the distances always from pole, right? So from object take a ray towards the pole. So the direction of the incident ray is towards left, right? And now measurement of the object distance PO. We have to start from P and go to O. It is towards right, right? So object distance will be, we are already given. So not given, right? So let the radius of curvature of the, let the radius of the sphere be R. Right? Then PO will be minus R. Right? P to O towards right. It is towards right direction. P to O is towards right. Incident ray direction is towards left. Both are in opposite direction. So PO will be minus R. Radius of curvature PC will also same again. PC, PO both are same. That is why PC also minus R. Right? So let us substitute the values now. N2 value is 1. V, image distance we have to calculate, minus N1 is 1, U is minus R is equal to, sorry, N2 is 1, N1 is N, right? So N2 is 1 minus N by minus R now, right? Radius of curvature is minus R. Object distance is also minus R. Implies 1 by V plus N by R is equal to 1 by minus R minus N by minus R, right? So this is minus. So minus minus will become plus, right? Implies 1 by V plus N by R is equal to 1 by minus R plus N by R. N by R on the left and right side you can cancel directly. Implies 1 by V is equal to 1 by minus R. Implies V is equal to minus R. Means image also will be at the same distance as the object. That is why apparent position of the dot will appear to be same as its actual position. In other words, so image distance also minus R. In this there is no N. So that is why here the image distance won't depend on the refractive index of the glass, means it is independent of the refractive index of the glass, right? Thanks for watching. Not using